Alright, this is 8.4D, where we're solving multi-step equations. Okay, so the first step always is to distribute. If there is a possibility to distribute, you have to do that first. Then, if like terms are present, you must combine like terms. And then from there, we do the same thing as before with reverse PEMDAS. So add and subtract before you multiply or divide. Okay, so in this example, we can't distribute, but we do have some like terms. 3x plus 1x is 4x minus 6 equals negative 18. We're going to add 6 to both sides, and we end up with 4x equals negative 12. And now, because 4 is being multiplied by x, we're going to divide by 4 on both sides. Negative 12 divided by 4 is negative 3. And then we can plug it in to check, and negative 9 minus 9 is indeed negative 18. Alright, for this example, we have parentheses, so the first thing we need to do is to distribute. So the 7x is just going to come down. 2 times x becomes plus 2x, and 2 times 6 becomes plus 12. Alright, now we combine like terms. 7x plus 2x is 9x. And now to start unwrapping to get towards the x, we got to subtract 12 from both sides. We get 9x equals 27. Then divide by 9, and x is 3. And you should plug that back in and make sure that it works. Alright, so part of solving equations is dealing with fractions. So when you see a fraction outside of parentheses, like these two examples, you have to decide whether to distribute or multiply by the reciprocal. Technically, both will work. It's just that one is going to be easier than the other depending on the situation. So it's easier to distribute if the denominator goes nicely into both numbers inside the parentheses. And since 2 would go nicely into 4 and 2, this would be a situation where you distribute. Alright, but if the denominator is not going to go nicely into the numbers inside, then that's going to be a little more difficult. So then, because this numerator will go nicely over here, if we end up multiplying by the reciprocal on both sides, then since negative 14 and 2 will work nicely, that's going to be our easier option. And again, both will always work, it's just a matter of how many fractions you want to end up dealing with. Alright, so in this case, 3 is going to go nicely with 1 and 3. So we're going to go ahead and distribute. So we get 1/3 times d plus 1/3 times 3 equals 5. And that just becomes d over 3 plus 1. Since 3 over 1, since those end up canceling, equals 5. And again, to get into this variable, we have to subtract 1 first. You end up with d over 3 equals 4. And then because we're dividing, we have to multiply by 3 on both sides. And so d equals 12. And again, you should always plug that back in and make sure. Alright, for our last example, 2 is not going to work nicely with 5. So in this case, it's going to be easier to multiply by the reciprocal. And the whole point of doing that is to get rid of the fraction. So I'm left with x minus 5 equals, well, negative 6 times 2 is negative 12. Divided by 3 is negative 4. And now, to solve for x, I can just add 5 to both sides, and I get x is 1. And since we're talking about justifying with the property that allows us to multiply by a reciprocal and get 1 is the inverse property of multiplication. Alright, so if I was justifying that first step in solving this equation, it would be the inverse property of multiplication. And then if I was justifying the next step, it would be the addition property of equality, because I'm adding 5 to both sides. So remember, the properties of equality come in anytime it's whatever you do to one side, you do to the other. And that's it for this section.